Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd have another look at the EverReady Sky Baron. If you remember in the last video, we completely stripped this thing down. I've basically got all its guts in this box here. And what I thought we would do today, I'll get them out of the way. Hang on, let me move the cabinet out of the way. And thanks to my mate Steve, I do have a nice piece of veneer here to re-veneer the cabinet. Now this should be large enough to re-veneer the whole cabinet, everything that's bad on it. So we'll do that in a separate video. I'm not going to be doing that in this video. What I thought we'd concentrate on in this video is more of what I've got in here. Get some of the bits. We've got this really tarnished bit of trim on the dial there. We might have a look, see what we can do about that, see if we can improve that somewhat. And the other thing is, I want to have a look at the actual radio chassis here. Now we know it works perfectly, but I'd really like just to get in there and have a little bit of a closer look at it. And there's one capacitor in there that I might look at changing, just for the simple fact it's an electrolytic. They can fail. It's not going to kill the radio, I don't think, if it actually if it just went open, but it will affect the sound quality of the radio. So we'll have a quick look at that, and we might just swap that out for a modern one. I probably won't actually change any of the other capacitors. I'll go into the reasons why when we delve into it. So I'll get this out on the bench, I'll get the camera pointing at this, and we'll crack in and have a look what we're doing. Okay, so here we are, we've got the guts out on the bench here. One thing I want to do is address the power connector there, because obviously we're not going to be able to plug a modern battery into there, so we're going to sort that out. What I thought we'd do, it is going to be a bit tricky because simply by the way that this thing has been designed, it's not easy to get apart. We've basically got like a sandwich construction where we've got the PCB on the bottom there, and then this metal kind of chassis on the top here which holds the tuning condenser and this intermediate transformer. Can you actually see where I'm pointing here? This intermediate transformer here. What I will try and do is just loosen off that screw. I think it's that screw there. Yeah, that screw there. I'm going to leave the transformer. In fact, I could possibly take the transformer off and leave the transformer. Yeah, I'm going to do that. Let me grab some screwdrivers. We'll try using these again. I've found these screwdrivers incredibly useful since I bought them, and like I said, they were only cheap. And some pliers as well to deal with them. Right, let's take them off. Now, some chap actually commented on my previous video, and he did confirm what I thought, that this shares the chassis with one of the EverReady portable radios that was out around the same time. I think the chap said he actually worked at the plant that built these. Right, let's have a go there. There we go, that's that one out. Let's try this one. There we go. That's that one out. I wonder if I can do the same with the tuning condenser. Then we can just lift this plate clean off. That's turning. These are quite stiff, but that's turning. Yes. So we'll take them out, and then we can just lift this plate right off and leave everything connected up. Okay, there we go, we're in. And it is really, actually really nice and tidy in here. Drop them screws out, I'll have to put them screws back in after when I reassemble it. Just get that out of the way. Right, and essentially, the only capacitor that I'm actually concerned about really is this one here, which is a little 50 UF electrolytic. It's probably rated about, I don't know, 10 or 20 volts, something like that. It'll only be a probably about 20 volts, being that the battery I think is 9 volts. That is the only actual capacitor I'm really concerned about. All the rest of these capacitors are the old-fashioned wax paper capacitors. Now, if this radio had the Hunt's mould seal capacitors in them, I'd probably consider changing them. The problem with them Hunt's mould seals is they've got like a little kind of like ceramic coating on them. There's still a paper capacitor, paper and foil capacitor inside. And what happens is it cracks and crumbles and allows moisture in there, and they start breaking down. They basically go short circuit. These wax paper capacitors, now they will break down if you put a reasonably high voltage on them. Most of these wax paper capacitors, if you put a couple of 100 volts on them, they'll start to break down. What I've found though is in transistor radios where they've only perhaps got 10 volts or 9 volts or so on them, they don't seem to go wrong. They do seem to last in these circuits incredibly well. So basically I'm not going to change, and the radio works perfectly. It works really, really nicely. None of them look cracked, none of them look distressed. They are looking at, in fact, let me see if I can zoom you in a bit so you can have a little bit of a closer look at what I'm showing you here. Let's see if I can just, there we go. How's that? Right, this is what I'm talking about. In fact, we've got two electrolytics, so we might be changing both of them. We've got another 50 UF there. Oh, is that an electrolytic? We might actually have more electrolytics in this than I first thought we had. Yes, we do. And we've got a Hunt's mould seal in there, which I didn't realise we had down there. We've got an electrolytic there. One there, and I believe that may be one there. Like I said, these little wax capacitors, that one, that one, that one, and that one. From experience, like I said, they generally don't go wrong in transistor sets. They only seem to go wrong in valve sets where they're subject to a couple of 100 volts, like the 9, 10 volts, 12 volts maybe, that they see in a circuit like this. They seem to very, very, very rarely go wrong. The problem with the electrolytics is basically they just dry up over years. They have a little rubber seal on the top here, that's a little bit of red you can see, which should be a soft spongy rubber. And actually, amazingly, well, they do actually still feel quite soft and rubbery. What you normally find is that rubber on the top and the bottom, you have a black piece on the bottom for the negative and a red piece on the top for the positive, obviously, tends to go really, really hard, cracks, and then, like I said, obviously because they're a wet electrolytic, they dry out and basically stop working. But what I think I might do is I might pull out one of those electrolytics and we'll test it on the ESR tester and actually see what it's showing us. That might be rather than just guessing and just changing everything on for the sake of changing it. Let's pull one out. We'll whip this one out and we'll test it on the ESR tester. That's super hard solder. There we go, it's coming now. you do have to be very careful when you're desoldering from these early circuit boards. It doesn't take a lot to lift traces. They're quite susceptible for lifting the traces on these. In fact, I might actually switch the desoldering station on and use that to remove the solder. That one's free there. Let's just see if we can just sneak it out. There we go. Right, that's our first electrolytic out there. Get you down a little touch. Right, that's one we've just extracted that we just want to test. It's 50 UF and it is at, oh, it's only at 6 working volts, this one. So 50 UF capacitor at 6 volts. I'll bring in the ESI meter. And we are looking at 47 is as close as we can get, and 10 volts. So we're looking around something around about an ohm, basically, for a good capacitor. Let's switch the meter on. I'll have to short the probes to compensate it. There we go. That's set. We'll connect the capacitor up. As you can see, that is really high ESI, 2.63. We want around 1. Well, you know, anywhere below 1 is will be a good reading. So we can tell that is high ESI. So even though the capacitor looks really quite good, it is starting to fail. So we will probably go ahead and change all them out. In fact, I just need to find, we've got another 50 UF there. I'm guessing if one of them has started to fail, then the rest are probably starting to go as well. I'm trying to see what other size that is. What we got there? We've got an 8 UF there. And we've got, I'm guessing it's probably something around about a 10 there. Let's have a see. That's another 8 there, but it's obviously a higher working voltage. So, oops, you can't see what I'm showing you. So we've got, there we go. We've got another 50 UF capacitor there. We've got an 8 UF capacitor there, and we've got another 8 UF capacitor there. Now, judging that that one has already shown that that's high SI, I'm going to just have a quick rummage around, see what I can find to replace those electrolytic capacitors. We've also got one Hunt's mould seal capacitor there, which, like I said, amazingly, actually, it's not cracked. In fact, it doesn't show any signs of any distress on it at all. If that was cracked, I'd change it on site. Because it isn't cracked and the radio sounds perfect, actually, I'm probably going to leave it on this instance. I mean, I don't think it is going to cause a major problem. Them electrolytic capacitors, though, are starting to fail. Like I said, we're definitely going to want to swap those out just for future-proofing of this radio. Because I'd love it to be able to run until they switch off analog transmissions. And even back then, even after that, we can use a little micro transmitter and still play music to it. So I will see if I can dig out some capacitors to replace those. So I will be back as soon as I've done that. So back in a sec. Okay, we're back, and as you can see, I've got some replacement capacitors here. Now, I will freely admit these aren't new. I just salvaged these off a scrap modern board. But if we bring the tester in, let's fire up the old ESI tester, and let's see what the ESI reading on these is compared with that old one. Remember, that was 2 point something on the old one. I'll take one of these 47s. So that's a 50. We're going to have to go down ever so slightly on the on the side, on the sides, these are 47s, but they're also slightly higher voltage rating, so they're going to be very undistressed in what they're basically doing. Okay, there we go. If you can see there, that's under an ohm. We're can you actually make that out? I'm not sure, but we're actually at 0.90 of an ohm. So much better. Even though, like I said, they are used capacitors, they're still in good condition. I've tested them all. I've tested all 4 of those. What we've got is we've got 2 47s to replace the 2 50 UF, and I've got 2 10s to replace the 2 8 UF. So we'll get those installed. In fact, we can pop that first one straight in there. Make sure I've got one of the 47s. Yes. Negative to that side, positive to that side. Unfortunately, the way the holes have been done in this board, it suits a it suits either an axial or a radial capacitor, depending on how you bend the legs. And push that through. We'll solder that in place there. And add a little bit of extra solder. Fortunately, because I have pulled these out of a board, the legs are basically already pre-tinned. There we go. The other side, okay, yeah, we're happy with that. So that's the first one replaced. Let's pull out the other. We'll pull out the other 50 UF, which is here. The negative lead, sorry, the negative lead comes from the bottom there, so that's the positive on that side. Let's see if we can just heat this up and just see if we can rock this one out as well. The other one will come out quite easily, really. There we go, that's out. And hopefully we can get this one. Just got to find out where that other. Right, we're right there. So it's that one there. See, unfortunately, what they had a tendency to do when they was building these is to actually bend the leg over as they inserted it like that. Because what they do is they put all the components in, bend the legs over, then flip the board over and solder it in most instances. So the positive is that onto this side here, negative straight down. In fact, let's just give that a quick test on the ESR meter just for fun. Okay, and we'll connect this up. Positive on that side, negative on that side. And as you can see, we've got 3.3 ohms. So again, that one is somewhat high on the ESR compared with these we're replacing them with. That's a 10. That's the other 47 there. And that needs to go that way in, like that. Oops, I've dropped it. going to try and do is just basically get the legs in the holes, hold it in there and just heat the solder up on the other side, and hopefully just be able to push them back through. So they are a bit of a mare, the printed circuit boards on these early printed circuit boards. They don't like heat, and they do have a tendency to lift traces if you're not careful. That went in. There we go. That's it. That's in. The one advantage of using reused capacitors like this is that the legs are basically pre-tinned up, and you can just push them in like that. So we'll change this one here next, I think. I'm actually starting to doubt myself whether I put that one in the right way around now. We can check that in a minute anyway. We'll check that at the end. It's easy enough to check. So let me have a look where this one goes. There's some resistors around there. It's in line there. I think that's the connection for it, or at least one of them. So we'll try heating that up and see what happens. This solder is very reluctant to flow as well, which is, yeah, that's one of my connections. There we go, that's free. Let's see if we can get a bit of that off. That's one of our connections free for it. Let's see where the other one's going to be. Right, so that's the main capacitor out, and the other side of it, so that's the positive connection. This one here should be the ground. Hopefully you can see what I'm doing here. Yeah, that's the ground connection there, so let's see it move there. I can just keep moving it round. There we are. And we can get a bit of solder off it. Off you come. Right, let's see if we can get that out. Again, I said they did have a tendency when they was building these to put little hooks basically fold the end of the wire over, and it does make removing them a tiny bit tricky. Especially when you've got a board like this that the traces lift for fun. Let's just flop that down again and pull that out. There we go, that's out. So our first connection there is the positive. Go on, we'll test that one as well. We may as well test them all as we pull them out and then put the new ones in, or maybe not. Bugger. That's what you get for buying cheap Chinese crap. Hang on a minute, I'm just going to pause the video and see if I can just sort this out. Okay, well I've fixed that again. It just basically the solder connection there is just broken. Anyway, let's test this capacitor. I'll zero that out. Okay. Now this is an 8 UF at 6 volts, so closest we're going to have to test it as is a 10 UF at 10 volts, which will be a 10 UF at 16 volts. Let's see what it comes up with anyway. So that is positive that side, like that. Negative there. Oh wow, 10.3 ohms. Yeah. And let's test one of the new ones. Well, when I say new ones, one of the replacement ones. Connect that up. And there we go, that's 1.5, which is basically what it tells you for a 16 volt 10 UF capacitor. So that is bob on, perfect. The other one was obviously very high SR. So it just goes to show, even though how well this radio was playing, it still did have components which are starting to go in it. So hopefully what we're doing now is going to keep it working for some time to come. Now that is positive straight down, so that is right that way on. We've got it there. Let's put that in there. Just going to squeeze that in a little bit. There we go. Just hold that with my finger while I spin it back over. And if we're lucky. Oh, it's not going. I've got both them holes nice and get my pliers and just tidy these legs up a little bit. So we can get them down into the holes. That's better. And hold that in place with my finger like that. You can see both legs poking through. And just try tacking that one. Tacking that one. We can solder them into place properly now. Do that one. There we go. And we'll just finish that one off. There we are. Right, we'll do that last electrolytic, and then I think we'll just go back and we'll just double check that first one there, because I'm not 100% sure I've actually put that one in the right way around. We will check that in a minute. But we've got one more electrolytic, which is this one right back there near the aerial coil. That's going to be a pain to get to because of where the tuning condenser is, but we can manage it. I think that's a connection for it, isn't it? Is it? That one is there. Oh right, wow. Okay, so they've come through that hole and they're actually using the leg to bridge across onto another point there. That was a bit naughty of them. So I will cut that there and bring that out of the way for the moment. We'll get that capacitor out of the way and then we'll have to remake that connection. Right, that side's out, and that there is the other side of it. There we are. Out you come. Bit of a pain to get to because I can't really get my fingers on it to pull it, to effectively pull it out. Coming now though. Just being a bit of a swine, this one. There we are. And the other side of that I'm fully decided. There we go, that's it. out we come. So we've got positive on the top, so that's the positive connection there. And again, we'll just test that just for completeness. Right, where are you? Where's Mr. Tester? There he is. Okay, and negative to the bottom there, positive to the top. Not quite as bad as the other one, but it's still pretty high. 8.6, 8.7, going up 9. Let's see if we compare that with the replacement. There we go, 1.6. Right, so we can get this one in there. We want, which leg was which now? That was the other one, weren't it? Yeah, long leg. Yeah, long leg was the positive leg. So we want this one to go in that way round. Again, I'm going to have a bit of fun getting this actually into position, so just bear with me a second here, folks. I will say that working on all valve radios, you have a lot more room, generally speaking. They're nowhere near as fiddly. Oh, bugger. That landed up on the floor. Ah, got ya. I really don't want to take it apart more than I have to, if at all possible. That way around. See if we can just move that out of the way a little bit while we get in there. Nail it. Got ya. Right, I'm sorry if you can't see everything I'm doing here, folks, but this is a little bit on the fiddly side. One of my legs has come out of its hole there. Damn state where I put you. I'll have to pull that back out and try again. I will just redress these leads. Give me a little bit more working room. There we go. Let's try that down. One side in, that's the other one side in. There we go. That's more like it. There we are. Got that one to poke through. Got that one to poke through. Lovely. Sorry about that, folks. That was a bit of a... That one was a little bit of a mare to get in there. Let me just solder that other connection there. Right, sorted. Let's touch that in. A bit more on there, and I'll just trim that leg off because it's a little on the high side. I thought it's no higher than the rest, but there we go. And then we've got to solder that wire. That was actually part of the original capacitor leg back over onto that connection there. Because what they've done is they've pulled it right through the board, they put a piece of sleeving on it and bent it over onto another connection there to make like a jumper wire. There we go. That's joined back in. So that's that connection remade there. That's all the electrolytic capacitors changed. So I'm not going to change. Oh, and we need to just double check that one that I'm not sure about at the front there. Did I put that in the right way round? That is the question. That's one of these, so it should be negative to where the... You know what? No, I didn't. I put it in the wrong way round. You silly sod. We'll have to pop that one back out and just swap it round. Out you come. Come on, out you come. There we go. It should be going in that way. Again, I just need to put a little extra solder on that. You have to be really careful when you're doing something like this, you don't break one of the wires off while you're manipulating the board round. You're just wanting a little bit of extra solder on there. There we go. That's that done. There we are. Coffee lock, yeah. Right, so basically, as far as I'm concerned, that is all the components I want to change in this radio, actually changed out now. I'm not going to go mad and change out all the, like I said, all the wax paper capacitors. Generally speaking, I don't think those are going to fail. We knew the radio was playing really nicely, so it's not giving any indication that they're failing. So what I think I'll do now is we'll reassemble it. I'll put it all back together and we'll just give it a quick test, make sure we haven't done anything terribly wrong with it and stopped it actually working. And then we'll have a quick look at see if we can sort that sort that bright work out. See about putting this back together first. Just get that to lock onto them. Okay, in you go. Thing is, once you get the first one of these in, it's a lot easier to get the rest in then. Always getting the first one in is can be a bit of a pain. And the rest should line up. There we are, that's that one. That's them all tightened up. And we've got a screw there to go. Those two screws. We've got one screw missing at the moment. Let's see if we can find it. There it is. That's all the screws we need. We've got one more that goes in there. Like that. And then we've got to put that transformer and screw that back in place underneath there. And that should be reasonably easy once we've got the first fixing in. Put that in like that. I'll get that under there. I'll guide that in with a screwdriver on it. There we are. Pull that up through, and I'll just hold it there with the screwdriver while I get the nut on it. There we are. Lovely. And this side should be a lot easier because we can actually get in a bit. There we are, that's that one in. Again, we'll get the screw on it, so we get the nut on it. Okay, lovely. Oops, I nearly lost my glasses again. Right, we can get that tightened down. Just do that one up. These don't need to be mega tight. Okay, there we go. Just nip them two up. And we better just connect it up to the bench supply, and we'll just do a quick test just to make sure we haven't done anything horrendously wrong with it. Let me get you so you can actually see it a bit better. There we go. Switch the bench supply on, and we'll drop that down to 9 volts. Black to black, red to red. There we go. So it's still playing. Turn that off now because I don't want to get a copyright strike. But obviously we're still working nicely. So the only thing really left to do with the actual chassis is obviously they don't make the Pp2 battery that this thing used to originally use. So what I'm going to do is I'm going to convert it to use 6 of the C-cell batteries. And with that in mind, I've got a holder here. Well, actually, what ended up happening, I had a look online for these. So it takes 6 C-cell batteries, which will give you your 9 volts. But this will last significantly longer if you want to use this radio in regular use. And if you used a AA batteries, obviously, like I said, this is more akin to like the capacity of the pack that this radio would have originally had in it. And obviously, if you was to use alkalis or something here, it would last them quite a considerable amount of time. But these were, I think there was £3.95 each, plus £1.95 postage. So about it worked out around about the £5 each mark. Or I could buy a pack of 5 of them for £9.99, including postage. So I've got a few spares basically. It didn't seem any point just buying one when for the price of 2 I could have 5, and that included the postage as well. So we're basically going to take that connector off there and add that battery connector to it, that battery holder to it, and then that can go back into the radio. Get you zoomed out a little bit, so because I'm, oops, there we go, that's better. Oops, there you can actually see what I'm doing now. There we are. Right, so let's get this. I would normally keep something like that, but to be honest it's broken anyway, so let's just get rid of it. Because these type of connectors were used for other things. I've seen them used for speaker interconnects inside old valve radios and stuff like that. If it won't easily desolder, we'll... oh, there we go, that's out. If it weren't broken, that'd go into my it might still go into my spares bin actually, because you never know when you need one of these pins for something else. There we go. Come on, in you go. There we are, that's off. We'll take that off, and we'll take the little retaining card off as well, because we don't need it. It's actually just a piece of dial card that they've repurposed as a strain relief. Let's get rid of that. So we've got 2 wires there. We will just bend these tags out slightly. I mean, these are this is a fairly cheap holder. It's not top quality, so you do have to be really careful when you're soldering these, that you don't dwell too long on the actual thing. It's really hot iron and get in and out as quick as possible. That's my tip of the day for when you're soldering these plastic battery connectors. Our wires there are already nicely tinned up, so we'll just add a bit of solder to the connections, and we are going to do a really quick. There we go. Oops, no, that didn't stick. That did. And the positive one as well. There we go. I've got 2 connections on there. I'll do the black first. The negative first. I'll connect the positive on. There we go. So that is our new holder. Like I said, we've got this, the radio we know is good now. We've changed them electrolytics out. They would have probably gone on for quite some time with the old electrolytics in, but they are starting to go. So you can see that the ESR is going quite high on them now, compared with even them used capacitors that we actually fitted in there. Like I said, they are modern capacitors. They're less than, in fact those are less than 5-year-old, I think. They literally came out of a piece of equipment that was perfectly working, it was just obsolete. Such as modern, modern AV and modern. In fact, it was a Sky television box that someone gave me, which I used the hard drive in another project. And the box had basically only ever been kept as in a second room box anyway, so it's really never really been switched on. But it was obsolete. It's no use for love nor money as what it was. So the parts in it are still recyclable and reusable for things like this. Anyway, that's the back of the bench. And this is the last thing I'm going to really look at in this video. I don't want these videos to drag on and make them too long. Let's see if there's anything we can do with this. I'll get you zoomed in. Oops. In, not out. There we go. Get you down a little touch. Right. I mean, one thing, the plastic itself is a little bit mucky and dirty, but that will come up nicely with some teacup. We can get that looking reasonable with some teacup. The problem is, and at first I thought this was actually plated, like just a tin or something that had been plated with a brass, and that's why we had this tarnish in there. I thought it was actually where it had worn through. It's not. This is actually something that's reacted with the brass and caused this red colour. Because what I did, I got my little bronze brush here and started rubbing on it like that, and it actually comes off. I was wondering though, how hard is it going to be? If this won't work, then we'll resort to cleaning it in situ. But I'm just wondering how stuck on is the actual glue that's holding that brass bit. Unfortunately, it's not got any little tabs or anything through the back holding it on. It's glued in place. And I don't want to risk bending it up trying to get it off. So if we can't get under it easily and flick it off, we'll clean it in situ. I'm feeling we may end up actually doing that, because like I said, I don't want to risk messing it up, try to pull it off and bending it or anything like that. So in fact, we'll do it now before we clean this up. I'll probably clean that up off camera because it is quite laborious, but I've got a bit of wire wool here, and I'll just want to see how. Oh, look at that! You see that? We try to keep the wire wool off the plastic, and we're just literally going on the brass part, the really tarnished brass part that looks manky. You see that? This is the worst bit there, where it's got that mark on it. Again, if we get on the wire wool, you just have to be super careful that you don't scratch the actual perspex while you're doing this. That's why I would have rather it had come off easily. I would have actually taken this. I would have taken this off to do this, but sometimes you risk doing more damage by removing it than you do cleaning it in situ, providing you're dead careful. Try and keep all your polishing going in the same direction. What you don't want to be doing is doing that and then a bit of that, because you'll end up with like a crosshatch kind of pattern to your dial. You keep it always going in the same way. Like I say, we're being super careful not to rub on the perspex in the middle, because we will mark it and make a mess of it. I mean, it's not, we could get that back out again, but if we're careful, we're not going to damage it. There we go, as you can see. Look at that now. There's a little bit left here I just need to go over. There we are. Look at that now. That's took all the tarnishing off. Now, unfortunately, this will dull fairly quickly. So that does clean that up really nicely like that, but that does dull off really, really quickly. If I could get this off easily, what I'd do is I'd just put that on a piece of card and spray it with a high gloss lacquer, a clear high gloss lacquer, which will stop it tarnishing again. What I'll probably have to do in this instance is mask all this up with some masking tape and actually spray it in situ. I'll probably do that off camera, to be fair, because I'll have to do it either outside or down in my summer house, because I can't really do that. Can't really do that in here. It's a little bit too smelly for that. I've also got to see if I can source a bright for the centre there, or see if I can make one. I wish years ago I actually made a punch set for making them. I did have access to a machine shop at the time. Unfortunately, I don't have access to that machine shop anymore, so I can't make another one. But no, it was a really cool little thing like that, a little cylinder like that, and you put a piece of brass in it and a plunger on top and whacked it with a hammer, and it cut a perfect circle out and actually domed it. And it was made specifically for making replacements for the centre caps on things like that. So unfortunately I haven't got a clue where it's gone over the years. Anyway, right, so I'm quite happy with how that's come up. In fact, where's that bit of trim? We'll just have a go of the same trick on a bit of the trim that goes around the radio. Just see if I can just find a piece. I'll put them up here out of harm's way. There they are. Because essentially these are exactly the same. These are the trims you saw me remove in the previous episode. So we managed to get them off nicely, but they are really, really tarnished. And just watch this. We'll do the same trick on them. A little bit of wire wool. Really, really gently. But can you see that literally in the front, in your eyes? If you look there, you can see the piece. That's the bit that I haven't done there, and that's how it comes up, with just a little bit of work, and it's just basically just wire wool. It's abrasive enough to take all the tarnishing off, but not abrasive enough to really, really scratch up the metal. And again, the same with the dial bright there. Once this is all cleaned up, I will have to give it a blow over with a lacquer to stop that tarnishing up again, because it would have had a lacquer on it originally, and basically over the years it's gone bad, and it's started to tarnish the metal underneath. But it does come up really nicely like that if you give it a little bit of a treatment with some wire wool. Anyway, I'm going to leave it there for now. This is going to be part 2 of this little restoration. So in the next part, we've still got that dial, the speaker cloth, not dial card, this doesn't have a dial card. We've still got that speaker cloth that we need to have a look at. That needs a really, really good clean, and it needs some repair work. And once we've got that done, we're on to this. We will have a look at doing the actual re-veneering on the cabinet. So we'll probably have a look at the dial cloth and doing the re-veneering in the next video, and then we'll probably actually do a part 4 where we actually reassemble it all and do the final finishing and everything. Anyway, I'm going to leave it there for now because this video is already going to be long enough. So I hope you enjoyed that little update on the project. Thanks for watching, and goodbye.